Hi, for this video what I want to do is show you how to solve a systems of two equations word problem. So what we have here is Joe's school is selling tickets to the annual talent show. On the first day of sales, the school sold 6 senior citizen tickets, so that's important, and 5 student tickets for a total of $130. The second day, they sold 12 senior citizen tickets and 13 student tickets for a total of $284. And what it asks us to find is the price for one of each type of ticket. So we're trying to figure out what is the cost of one senior citizen ticket and what is the cost of one student ticket. So the first thing that you want to do is anytime you're solving a system of two equations, you want to identify variables for both of them. Since both of these variables start with an s is not the best variable, so I'm just going to use x and y, and I'm going to let x be the price of one senior citizen ticket. That way, when you get to the end of the problem, you remember which variable represented what, because it does make a difference if you reverse the order. The second one that we would have is the price of one student. Okay, so now once you've identified your variables, you're going to set up your equation. And to set up your equation, we're going to pull out that important information that I already underlined. So I had 6 senior citizen tickets, so that means that I have 6 x's, plus I have 5 student tickets, which I used y for, and that cost a total of $130. So combined, if I added these all up, it would be $130. So then we want to check, or we want to set up our second equation. So we would use 12x plus 13y equals a total of $284. So again, all I did was pulled out the important information, set it up as a system of two equations. Make sure that you always identify what your variables represent, because it's very important at the end that you solved for the right thing. Now with this, what I'm going to do is I'm going to use elimination. I wouldn't use substitution on this because if I tried to solve, I would end up with fractions, and it's no fun to work with fractions. So what I'm going to do is I'm going to eliminate. Remember, to eliminate, we need the opposite numbers in front of either x or y. It doesn't matter which one you do. So for this one, I can't multiply 5 by something to get 13, but I can multiply 6 to get the opposite of 12. So this is the variable that I'm going to choose to eliminate. Now we need to figure out what would we multiply 6 by to get the opposite of positive 12. So the opposite of positive 12 is negative 12. So we would multiply the entire top equation by negative 2. And we're going to keep this bottom equation the same because it's already 12. So I'm going to keep the bottom equation the same. If you wanted to eliminate the y's in this case, I would have to multiply the top equation by 13 and the bottom equation by negative 5, and so it's a lot more work. So once I multiply the top equation by negative 2, I would have 6 times negative 2, which gives me negative 12x, negative 10y, equals negative 260. So what we have is an equivalent expression. Okay, we've changed everything in there by a factor of 2, so it's an equivalent expression. My x and y would still remain the same. So I want to now add these two equations together. And when I do that, my 12x's cancel out, and we're left with 3y equals 24. And so then we can solve that y equals 8. Now remember, we have two variables that we have to find. So we want to take y equals 8 and plug it back into either equation. It doesn't matter. I'm going to plug it into this equation just because 6 is smaller than 12. It really doesn't matter though. So I'm going to plug it into this equation. So I'm going to keep this 6x plus 5, and I'm going to replace the y with 8. And now we would simply solve this system, or solve this equation that only has one variable, which is easier to work with. So we would have 6x plus 40 equals 130. And then when you subtract the 40 from both sides, we get 6x equals 90. So all I did was subtract the 40 from both sides to get that to cancel out. And then if I divide both sides by 6, we end up with x equals 15. Okay, so now when you're going to write in your answer, it's very, very important to remember which one is which is why we put this down at the beginning. Had you not put this down at the beginning, you might mix it up when you're putting in your answer. So it's very, very important to know what each of your variables represent. So we could say the price of one student ticket is, and so we would look to see, since we used student ticket was Y, see I tricked us because I put student first, so this is the one that we would have to report. So the price of one student ticket is $8. Okay, and then we would want to do the same thing for the second one. So we would say the price of one senior citizen ticket is $15. So because at the beginning we established which one was which, it made it easier to interpret the answer. And since we have found the price of one student ticket and the price of one senior citizen ticket, we have our answer. You can always plug it back in to make sure that it works. So if I do 6 times 15, that gives me 90. 90 plus 40 does give me the 130 that I need. If you plug it into the second one, it also works, so you can always check your work to make sure that it does. As always, thanks for watching. If you have any questions, please let me know. If there are any additional topics you need me to cover, please let me know that as well.